Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are starting the exercises of the chapter Probability from NCERT book. In this video we will be covering question number 1 to question 8. Now since we have discussed all the important terms and topics in the previous video, so I'll be starting with questions directly. So this is the first question of the exercise, which says complete the following statements. Here we have to fill the blanks. The first question says the probability of an event E plus the probability of an event not E. In the previous video, we had learned that if we define E as an event, then not E is written as P of E dash. This is the probability of E. That means the probability of any event is represented by PE, and the probability of not E is PE dash. And we had learnt a formula that probability of the event and the probability of complementary event PE dash, the sum of these two probabilities is 1, right? So probability of an event E, that means PE, plus the probability of the event not E, which is called complementary event, which is PE dash, they add up to 1. They are complementary of each other. So let me give you one example. If we have 3 red balls and 4 black balls in a bag. Now, what is the probability of drawing a red ball? The probability of red ball is number of favorable outcomes upon total outcomes. Total are 7. 3 plus 4, 7. So the probability of red ball becomes 3 by 7. And what is the probability of not red? What is the probability of drawing a ball which is not red? So in that way we can solve it. 1 minus probability of red. That means 1 minus 3 by 7, which is 4 by 7. So this way this formula can be used to calculate the event or the complementary event. Right? So the sum of probability of any event and the sum of the probability of event and probability of not event, that means probability of complementary of that event is 1. So the next question is the probability of an event that cannot happen. Now we have learnt these special types of probabilities. Probability of an event which cannot happen. Like I told you, if we throw a dice, the probable outcomes are 1, 2, 3, 4, 5 and 6. Now if somebody asks you what is the probability of getting 7 on a throw of dice. So to find the probability of any event, we have to write favorable outcomes upon total outcomes. So can you see there is no favorable outcome here in the sample space of this experiment. So there is no occurrence of 7 in the sample space. So we write 0 over 6. The probability of occurrence of 7 is 0. There is no chance that we can get 7 when we throw a dice. So the probability of an event that cannot happen is always 0. And such events are called impossible events. This is a special name, impossible events. Event that can never happen. This is impossible event. Right? The next question says the probability of an event that is certain to happen. Certain means the occurrence of that event is sure. That means it will happen 100%. It will occur for 100%. So the probability of, let us do this with an example. For a dice, the sample space is 1, 2, 3, 4, 5, 6. And if I define an event to get a number less than 7. Less than 7. As we know, all of the numbers here occurring in the sample space are less than 7. So how many favorable outcomes do we have? We have 6 favorable outcomes. So we write 6 upon total outcomes are 6. Since all the numbers are less than 7, so we have to consider them as favorable events. So favorable outcomes are 6 in number and total outcomes are 6 in number. So the probability becomes 6 by 6, which is 1. So the probability of an event which is bound to happen or certain to happen is 1. It's 100%. And such an event is called sure event. Sure event, or you can say certain event. Both are correct. Right? So these are two special cases, impossible event and certain event. Impossible events corresponds to the probability 0, which is the least possible value for a probability of an event. And for the maximum probability, it's 1, which is certain event. So the probability of any event cannot be more than 1 and cannot be less than 0. So it is always between 0 and 1, where both are also included. Probability lies between this closed interval. Next, we have the sum of the probabilities of all elementary events of an experiment is, see, if we make a sample space for tossing 2 coins, we have head, 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 tail, tail, head, and tail, tail. Right? These are 4 elementary events. We had learned the elementary event means any outcome of a random experiment is called elementary event. So we have 4 elementary events here. So see, the sum of probabilities of all the elementary events. The probability of occurrence of 2 heads is 1 by 2 multiplied by 1 by 2. That is 1 by 4. And probability of one head is 1 by 2 and 1 by 2. Right? This is also 1 by 4. Probability of tail is 1 by 2 into 1 by 2. Head is 1 by 4. And here also we have 1 by 2 multiplied by 1 by 2. This is 1 by 4. So if we add the probabilities of all the 4 elementary events, right? So if we add them all, this is 4 by 4, that is 1. The sum of probabilities of all the elementary events. We can also consider one more example. If we have sample space of throwing 1 dice, right? This is 1 to 6. Probability of occurrence of 1 on throwing a dice is 1 by 6. Added to probability of 2, it is also 1 by 6. We have an unbiased dice, and the probabilities of all the elementary events, they are equally likely possible. So the probability of every event is 1 by 6. If we add them, we get 6 by 6, which is 1. So whenever we add up all the probabilities of all the elementary events, the sum comes out to be 1. The sum of the probabilities of an elementary event of an experiment is 1. Right? Next, we have the probability of an event is greater than or equal to. Like I told you, the least possible value of the probability of an event is 0. And the maximum we are writing here greater than or equal to. That means the probability of event, any event, is greater than or equal to it. In exceptional case, it can be 0 or it can be some positive fraction, but it has to be less than 1. It cannot be greater than 1 because 1 shows the sure event or 100% occurrence of any event. We cannot have the possibilities more than 100%. So the probability of an event lies between 0 and 1, where both are included. The probability of an event is greater than or equal to 0 and less than or equal to 1. So in apart from these two exceptional cases, which is 0 and 1, we always have our probability as a positive fraction, which is like 3 by 5 and something, which is less than 1. 1 is an extraordinary case when probability is 100%, and 0 is another case where there is no chances of occurrence of the event at all. So probability of any event lies between 0 and 1. From 0 to 1, you can say. Next question says, which of the following experiments are equally likely outcomes? Okay, so now in this type of question, we have to use our common sense. A driver attempts to start a car, right? The car starts or does not start. So in general case, when we start a car, and 99% or we can say 90%, whatever, these are the random things. We cannot even fix a percentage to it. So it may happen that the engine of the car is not correct, or it may happen that since the car hasn't been started for a few days or few months, so the battery is not working at all. Whatever the case is, the car may start or may not start. We cannot have a particular solution to this. We cannot fix the outcome. And since the outcomes are not fixed, we cannot decide whether it will happen in a fixed rate or not. So such events, we can say that they are not equally likely possible. Not equally likely outcomes. Unless and until there is some malfunctioning in the car always starts whenever we give them a spark. So we cannot say what the condition of the car is and what circumstances we are performing the experiment. So we cannot decide what kind of outcomes this experiment will have. So the car gets started or not, we do not know at all about this. So we can say they are not equally likely possible. A player attempts to shoot a basketball. She or he shoots or misses the shot, right? Now here also, that depends on the quality of the player, how good he is at playing that. So whether he misses the shot or he gets through it, that is totally on the type of conditions he is playing and what kind of player he is. So we cannot say what kind of result we will have in this experiment. So we can say here, missing the shot or getting through it have no particular choices or no particular solutions to it. We can say they are not equally likely. As we have, I've already told you to that in the beginning, in the random experiments that we are considering in the mathematics are those experiments that, like whenever a player is playing, the same player may fail in a particular circumstance and he may perform very well in the same circumstances. So since the conditions are not, even keeping the conditions same, the result may vary. So such kind of experiments, we cannot draw conclusions for the results. So in this case also, we cannot say whether he will miss the shot or he will get through it. So the answers are not equally likely possible in this case also. Next is, a trial is made to answer a true-false question. The answer is right or wrong. Now, just try to analyze this. You have got one question, which is asking true or false. So if you have to answer this question, either you will make this choice or you will make this choice, right? If you make this choice, maybe this is right or maybe this is wrong. But still you have got only two options, and that option may be the correct answer or maybe it is incorrect. But still we have exact number of outcomes, as well as there are 50% chances that the option you have chosen is correct or incorrect. So in this case, at least we can stick to the answer and analyze whether it is correct or not, so we can get the mathematical probability. So getting a correct or incorrect answer is equally likely possible in this case. Equally likely possible or equally likely outcome, right? A baby is born, it is a boy or girl. So if we consider that whenever a child is born, we always take into consideration the gender of the child. So either he will be a boy or she will be a girl, right? So there are 50% chances of getting a boy or 50% chances of getting girl in this case. So sample space may be boy or girl. Like in case of coin, we just write head or tail. In this case, we will either be having boy or girl. So the number of outcomes is fixed, and there are 50% chances of getting a boy or a girl as a newborn baby. So they are equally likely outcomes, right? Next is, why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? So whether it is a football game or a cricket game, we always start with tossing a coin to decide. Why it is fair? Because see, whenever we toss a coin, the sample space for that experiment is head or tail. We are always restricted to have either of the two choices or two results. We will either get head or a tail. Since this is an unbiased coin and we have 50% chances of head and 50% chances of tail. So this is a fair mean of deciding whether if a person chooses head and he gets tail, the other person is allowed to give a choice. And if he asks for head and he gets head, he is given the preference, because this is exact fair mean to decide what is to occur here, right? So why is tossing a coin? Because since a coin has got two outputs and both the outputs have they are equally likely possible. They both have the same probabilities. 50% chances are of head and 50% chances correspond to occurrence of tail. Since both have same possibilities as a result or outcome of an experiment, we can say that it is a fair mean to decide who has to start the game, right? Which of the following cannot be probability of an event? This is a good question, and in the previous video we had learned few key points, that the probability of any event lies between 0 and 1, including both, right? That means it has to be a positive fraction. So if we take 2 by 3, yes, this is a positive fraction, it can happen. Negative 1.5. Probability of any event can never be a negative number. We had learned this in the previous video. Probability can never go negative. 15%. 15%, if we write it as a fraction, this corresponds to a fraction which is less than 1. So yes, this is also possible. 0.7. 0.7 is also less than 1. So in these three cases, we can have probabilities as the answer to an event, but we cannot have negative value for the probability of an event. So this is ruled out. Next is, if PE is equal to 0.05, what is the probability of not E? Not E is called complementary event. Complementary event. For complementary event, we had learned that probability of any event added to probability of complementary of that event gives us 1, right? So this is the formula we can use to find, or this is the relationship between the probability of any event and its complementary event. So probability of event is 0.05. So the probability of complementary event not E becomes PE dash is 1 minus 0.05. So it becomes 0.95, right? Okay. Now the next question says a bag contains lemon flavored candies only. Lemon flavored candies. Madhuri takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy? Right? So now the question says the bag contains only lemon flavored candies. And Marini is taking out one candy out of that bag. So what is the probability of orange flavored candy? Orange candy. Now you can see here we don't have any orange flavored candy in that bag, and still we are expecting it to take out orange candy out of that bag. So that is an impossible event. We cannot have an orange candy drawn out when we have a bag full of lemon flavored candies only. So the orange flavored candy, whenever we find the probability of an event, it is the number of favorable outcomes upon total outcomes, right? So the total number of favorable outcomes here is 0 because we don't have even a single orange flavored candy is not there in the bag. So how can we draw it out? So it's 0 and total outcomes are, they haven't given the total. A bag contains lemon flavored candies. Whatever the number of total output is, the probability of orange flavored candy is 0. Right? And the second part says a lemon flavored candy. Now the bag is full of all the lemon flavored candies. So whatever is the total number of, see, let's say, I'm just giving an example. Okay, let's say it has 10 lemon flavored candies, right? 10. So the probability of lemon flavored candies is the favorable outcomes are 10 here as well as the total outcomes are 10 here. So it becomes 1. For sure, it is sure that whenever you have a bag full of any number of lemon flavored candies, if you draw one candy out of it, you will always get a lemon flavored candy only. So this event is a sure event, sure or certain event. Since the probability is 1, you will definitely get one lemon flavored candy out of that bag, which is full of lemon flavored candies only. And this is impossible event. There is no chance of getting an orange flavored candy when the bag is full of lemon flavored candies. Impossible event. The probability of this event is 0. So it is impossible. The probability of this event is 1. So it is sure or certain event. Next question is, it is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Probability of different birthdays. Different birthdays, right? This is 0.992. It is given that in a group of 3 students, we have 3 students in all. The probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? So now here we are not we have not given these exact probabilities of having same birthdays of any 2 or random 2 or the other 2. So the different birthdays is 0.0992. You can see that probability of different birthdays and same birthdays, they are complementary events. Probability of different birthdays and probability of same birthdays. We can have either of two, so they are complementary. Either any 2 of the 3 friends or students have same birthday or they all have different birthdays. So same birthdays, they are complementary events. So they add up to 1, right? So the probability of different birthdays is 0.992. So the probability of same birthday can be calculated by the difference of these two. The probability of any 2 students having same birthday in a group of 3 becomes 1 minus 0.992. So we subtracted 1.000, 0.992. So we get, right, this is 0.008. And the last question is, a bag contains 3 red balls and 5 black balls. So red balls are 3 and black balls are 5. A ball is drawn at random from the bag. Now these are not equally likely. Why? Because the number of black balls is more, not equally possible, equally likely possible, right? So what is the probability that the ball drawn is red? Now we have to draw one ball from that bag. The probability of red ball is number of favorable outcomes. This is the formula for finding the probability in mathematical terms upon total outcomes, right? So number of favorable outcomes, as we are looking for red balls, so all the red balls are our favorable outcomes. We have 3. And total outcomes in total we have 3 plus 5, 8 balls. 3 by 8 is the probability of getting a red ball from the bag. Second part is not red. Not red. This is the case of complementary event. Probability of not red. As I had told you in the previous video, introductory video, that we have 2 different methods to get this value. I am preferring the second way to find this. So this is the formula. Probability of any event and probability of the complementary event. The sum of these 2 probabilities is 1. The probability of any complementary event is 1 minus the probability of that event. That means 1 minus 3 by 8. That means we have 5 by 8. So the probability of drawing a ball which is not red becomes the complementary event of the probability of getting a red ball. So we subtract the probability of red ball from 1, which is 1 minus 3 by 8. So probability of not getting red is 5 by 8. Or in this case, since we have only 2 options, red and black, if the ball is not red, it has to be black. That means the number of black balls divided by total. So it is 5 by 8. You can consider it anyway. Right? So this was, in this video we have covered first 8 questions of exercise 14. So please do not forget to subscribe, like and share it with your friends. Thank you.